Imagine a world where your daily gadgets suddenly turn into expensive paperweights. What could possibly have such a profound impact? Enter the realm of geomagnetic storms, mysterious forces born from the sun's own tempestuous nature. These storms have the power to cripple our satellites, darken our cities by knocking out power grids, and disrupt the very networks that keep our digital world ticking. As we increasingly rely on technology, the stakes get higher. This invisible threat is real, and it's called a geomagnetic storm. It all begins 93 million miles away with the sun. The sun, a vibrant furnace of nuclear energy, not only gives us light and warmth, but occasionally sends more explosive greetings our way. These come in the form of solar flares and coronal mass ejections, or CMEs. Imagine a solar flare as a colossal magnetic explosion on the sun's surface, releasing a tremendous amount of energy. Following closely are the coronal mass ejections, which are even more dramatic. These are huge bubbles of gas threaded with magnetic field lines that are ejected from the sun over the course of several hours. Both phenomena hurl charged particles into space at speeds that can exceed 1,000,000 miles per hour. This stream of charged particles is known as the solar wind, a constant flow that intensifies with every burst of solar flares and CMEs. As these particles race across space, they carry with them the magnetic fields of the sun, twisted and warped by their violent journey. And when these charged particles reach Earth, they set the stage for a geomagnetic storm. Earth has its own defenses against these solar assaults. Imagine a colossal, invisible shield surrounding our planet. A shield that is constantly at work to protect us from the relentless bombardment of the solar wind. This shield is Earth's magnetic field, an ever-present force field that extends thousands of miles into space. As the solar wind, a stream of charged particles emitted by the sun, hurtles towards Earth, it encounters this magnetic barrier. The magnetic field deflects most of these particles, guiding them around the planet. However, the interaction isn't always so straightforward. The solar wind can distort and compress Earth's magnetic field, creating ripples and fluctuations. This interaction forms what we call the magnetosphere, a dynamic bubble that reshapes and adjusts as it engages with the solar wind. Within this bubble, complex electrical currents are generated in the atmosphere. These currents can light up the polar skies with beautiful auroras, a mesmerizing display of Earth's defensive prowess. But sometimes, the shield is overwhelmed, leading to what we experience as geomagnetic storms. So what happens when Earth's magnetic shield fails to hold up against a solar storm? In this scenario, the impact on our modern civilization is not just significant, it's profound. Geomagnetic storms, potent disturbances in Earth's magnetosphere caused by solar winds, can have far-reaching effects on today's technology-driven world. One of the most critical infrastructures at risk is our power grid. The currents from these storms can induce additional currents in power lines, overwhelming electrical transformers and other components of the power distribution network. This can lead to widespread power outages. Imagine major cities plunged into darkness, not for hours, but potentially for days or even longer. The economic and social ramifications of such blackouts can be severe, affecting millions of lives and costing economies billions. But the disruptions don't stop there. Satellites, which play a pivotal role in everything from weather forecasting to global communications, are also vulnerable. A geomagnetic storm can damage these satellites or at least disrupt their operation. This means that GPS signals could become unreliable. Without reliable GPS, everything from your daily commute to critical military operations could be compromised. Furthermore, communication networks are at risk too. The same solar particles that dazzle the sky with auroras can disrupt radio signals and telecommunications. This can lead to a breakdown in emergency services when they are most needed, and even affect the functioning of international financial systems. The consequences are far-reaching, affecting everything from your daily commute to the security of nations. Understanding geomagnetic storms isn't just about scientific curiosity. It's a journey from the fiery surface of the sun, where these storms originate, to the delicate technological fabric of our Earth. These storms, powerful surges of solar energy, travel millions of miles, only to clash with our planet's magnetic shield. This shield, our planet's first line of defense, deflects most of the solar onslaught, protecting our atmosphere. However, when it falters, the effects on our modern civilization can be profound. Power grids can falter, satellites malfunction, and even our humble GPS signals can go awry, proving that our everyday lives are intricately linked to these cosmic events. The importance of understanding these storms cannot be overstated. As we have explored, by studying the science behind geomagnetic storms and recognizing their potential impacts, we can develop strategies to protect our technological infrastructure. Investing in robust, resilient systems and fostering international cooperation in space weather forecasting are critical steps towards safeguarding our future. As we grow more reliant on technology, understanding and preparing for geomagnetic storms becomes not just useful, but essential.